Okay, we start with let's have a beaker, with copper chloride, a beaker with copper chloride. This is copper chloride. Copper chloride is our electrolyte, a solution that conducts electricity by movement of ions. But in order for our copper chloride to conduct electricity, it must be dissolved. When you dissolve it, it breaks into copper cations as well as chloride anions. You dissolve it, and then when you dissolve it, you get copper cations, positive ions of copper cations. So here, negative ions of chlorine, we call those chloride anions there. So we break our electrolyte into copper cations as well as chloride anions there. Okay, now we are going to put graphite electrodes there. Graphite electrodes, they are non-reactive. They will not be participating in the reaction. They are just there for conduction of electrons there. Okay, and then let's connect our battery. Let's connect our power source, because the reaction that we are dealing with is a non-spontaneous reaction. It will not start without an external source of power. So it will not start without an external source of energy. So it requires an external source of energy to start. It's a non-spontaneous reaction in an electrolytic cell. And this is because an electrolytic cell, as opposed to a galvanic cell, is a cell that converts electrical energy to chemical energy. An electrical current will be used to drive a chemical reaction then. So the output is a chemical reaction. The input is electrical energy then. So now our battery will have a negative terminal, a positive terminal. The graphite connected to the negative terminal will be negatively charged. The graphite connected to the positive terminal will be positively charged then. Now, what is going to happen then? Copper cations, which are positive, are going to start to move to the negative electrode there. When they get there, our copper cations are going to gain 2 electrons and become copper there. Now, remember we said they are going to gain. Now, the gaining of electrons is called reduction there. So they are reduced. The copper cations are reduced. And then because they are reduced, after they are reduced, copper is formed. And because it's reduction, the electrode where reduction occurs is called a cathode. Therefore, this electrode of ours there is a cathode there. This electrode this side, the negative electrode this side, is a cathode. And you'll notice immediately that in this case, in an electrolytic cell, our cathode is negative as opposed to a galvanic cell whereby the cathode is positive then. Okay, so now, as copper is being formed as a product, we are going to see a layer of copper being deposited on top of the electrode there, on top of the graphite there. So the observation at that electrode will be a layer of copper there. So in short, copper cations are positive. They are attracted towards the negative electrode. When they get there, they gain electrons and become copper. Because we say they are gaining, that's reduction. The process of gaining electrons is reduction. The electrode where reduction occurs then is a cathode. Because copper cations are gaining electrons and undergoing reduction, therefore we call them oxidizing agent. A substance that gains electrons is called an oxidizing agent. Now let's go to the other side. Chloride anions are negative. They go towards the positive electrode. They go in pairs. So 2 chloride anions, each one loses 1 electron each, and then they come together and become chlorine gas. So you said that they what? They lose electrons. A loss of electrons is called oxidation. It's oxidation, and because it's oxidation that is occurring on this electrode, our electrode then is called an anode. Electrode where oxidation occurs is an anode then. Okay. Now, because chloride anions are losing electrons, then we call them reducing agents. We call them reducing agent. A substance that loses electrons is called a reducing agent, and chlorine gas is a product that is being formed at this electrode, and then as a gas is being formed in here, we are going to see bubbles of gas. We are going to see bubbles of gas then. So in short, two chloride anions go to the positive terminal, they get there, they lose electrons. The loss of electrons is called oxidation. Because we have an electrode that is whereby a loss of electrons is occurring and oxidation is occurring, that electrode is called an anode. And then because chloride anions are losing electrons, they are undergoing oxidation, then we call them reducing agents. Then reducing agents are substances that are losing electrons there, a substance that is losing electrons there by oxidation. Okay, we can also look at them by comparison. This is cations are attracted to this electrode, anions are attracted to this electrode. So let's compare. Negative electrode, positive electrode, cathode, anode. What occurs in this cathode is the gaining. What occurs in this electrode is the loss of electrons. Gaining of electrons is reduction, loss of electrons is oxidation. The substance that gains is an oxidizing agent, a substance that loses is a reducing agent. Copper is the product, chlorine gas is a product. We observe a layer of copper, we observe bubbles then of gas. Okay, so and then these are our the reduction half reaction. This is the oxidation half reaction for the electrolysis of copper chloride there. Okay. So we said that our reaction that occurs here is a non-spontaneous reaction. So the reaction is non-spontaneous, which means that it requires an external source of energy to start them. And because of that, the reaction that occurs, we say that it is an endothermic reaction. That means that it absorbs heat. It's a reaction that absorbs heat compared to a galvanic cell reaction that will release heat then. Okay, and then now we can also say that we have copper cations that gain 2 electrons to become copper, and we also have at the anode, this is at the cathode, at the anode we have chloride anions that lose 2 electrons to become chlorine gas. And then you can see this is our reduction, this is our oxidation. 2 electrons are lost, 2 electrons are gained. And then on the left hand side we have copper cations and 2 chloride anions. On the right hand side we have copper and we have also chlorine gas there. And then now this is our net cell reaction there, when we put our two half reactions together to have our net cell reaction there. Okay.